Good. What's up, everybody? Welcome to an extra special, super special. And when I say that, I really mean it. We've done 116 live streams in the Data on Kubernetes community. And this is our first time that we're going live and direct, getting local, getting really special with our friends that are out there in London, the UK. I'm in Madrid. I'm in Spain right now. We'll definitely be in London next month for our first in-person Data on Kubernetes meetup, which will be on March 24th. You can expect more information to be coming out about that very, very soon. But mark your calendars. On March 24th, we will be in central London, rocking out with our friends at Ondat, with other DOK community members. We're super stoked about this. Thanks to everyone for being with us today. Big shout out to Ondat for all their support. Big shout out to HashiCorp. Big shout out to Timescale and Caston that will all be joining us later. Got an extra special schedule for you today. Before we get started, I just want to drop a link here in the chat. For those of you that aren't aware yet, we will be having another co-located event in KubeCon in May, on May 16th, and our CFP is open. So if you want to give a talk about your experience running stateful workloads on Kubernetes, please take a look at the link that I dropped here in the chat. You'll find all the information about that for the CFP, which is open until March. So definitely get your talks in for that. We're hoping to have 2 tracks this time around to get more and more content about running stateful workloads on Kubernetes. Like I said, extra specially stoked. You've seen all the promo. We've done lots of extravagant things we haven't done before. We did a rap video before that normally we do afterwards just to get extra energy into this one. We even took a little clip from the movie Snatch, which I love and adore so very much, to hype up the fact that we're going local in London. You can expect to see more local meetups from us in the very, very near future. So once again, mark your calendars for March 24th. On top of that, I just want to highlight the fact that today, for today's session, we invite you to get involved in the conversation. Don't be a stranger. We're here to answer questions, to get these things out in the open. I'm going to leave the name for the Slack channel that we have in our Slack that's just dedicated to DOK London. All right, so feel free to get your questions out there. Also, if you haven't, for whatever reason, I'm going to leave the link to our meetup page for London. I'm also going to leave that here so you can sign up for that, so you can find out about all the events that are going to be going on locally speaking in the UK. All right, so I'm going to leave that link here right now. That being said, we've got an action-packed agenda, and I don't want to waste any time. So I want to introduce our speakers. We're going to have a hands-on lab talking about Kubernetes secrets, about encryption, about encrypting databases, persistent volume claims, all that good data on Kubernetes stuff. And that will be led by none other than my main man, Nick. And also he's joined by Dominique from HashiCorp. Very experienced folks, very generous community-based folks that'll be leading this. So we'll be spending about the first hour and 20 minutes, hour and a half doing a hands-on workshop. Remember, the first 10 people that finish this workshop successfully, all right, that finish this workshop, will get some awesome swag from Ondat and HashiCorp. I've also heard there's some backpacks, and not just any kind of backpacks, some North Face backpacks that will also be available for people that are participating, getting involved. We'll have some more information about that from Nick in a bit. That being said, I would like to bring on Nick and Dominique, but also remember, folks, after the workshop, we're going to have a DevRel panel. We're bringing on Lorraine as well as Allison to talk about the role of community in all this. We're talking about very innovative technologies. We're talking about bringing data, stateful workloads on Kubernetes. No easy challenge, and it's a technological challenge that has to be met with the human factor that we find in community, all right? So definitely stick around for the panel that will be after the hands-on workshop. That being said, I want to take it away and bring on our leaders for the workshop. But remember, folks, get your questions in the chat. This is for you, all right? You don't need any crazy technical requirements. You need an internet browser to be able to get involved in the workshop. They're very patient. These are folks that are used to doing this, that are very much on the educational side of onboarding folks with these different technologies. That being said, Nick and Dominique, could you jump on screen so I can get out of here?
Hi.
Hey!
Hello!
Hey, what's up?
Yo. Yeah, I'm all good. All good. Thank you for the kind introduction. How are you doing?
I'm pretty good. I'm stoked. I think that introduction went reasonably well. But no pressure. No pressure. I don't want to build up too much pressure for the workshop. But perhaps we can get a little quick introduction. Dominique, since this is your first time in our community, can you just introduce yourself? Tell us a little bit about your background, how you got involved in doing what you're doing.
Well, I mean, we only have a brief couple of minutes, but I'm Dominique Top. I am, at the moment, I'm a solutions engineer at HashiCorp. I've been involved in the DevOps community for, probably since the last 6 odd years. I am the Docker community leader for the London chapter. I'm on the organizational panel for DevOps Days London and DevSecOps Days London. I'm just involved with a lot of other communities in general. I just like being around people. So yeah, my experience is mostly there. I've had a stint as a recruiter, believe it or not, and
Ooh.
I have been a developer relations and community manager at my previous company. Was at Babylon Health, was for a short while, and now I'm solutions engineer at HashiCorp. So it's taken the long way around, but I'm still very much involved with all the cool communities in pretty much everywhere, but mostly in London.
All right, very, very good. And Nick, in your case, this isn't the first time we've had you on, so maybe you can tell us a fun fact about yourself that we don't know yet.
Oh, you already know everything. I don't hide any secrets. So yeah, my name is Nick. I'm a developer advocate with Ondat. Yeah, and I've been with you, Bart, on several occasions. We did like Twitter Live. We did some session around stateful apps and all the DevOpsy things. So today is no exception. I'm very hands-on. So we're going to do like a hands-on workshop. Very happy about it. I hope people like it because I spent at least 30 hours on that one. So if you hate it, tell it. But I will hate you for that. No, I'm just joking. Any feedback is always appreciated. Fun fact about me. You already know, like, I'm a big fan of animes, Marvel, hardcore metal. What else? Video games. Oh, I've just tried the new. It's The Lost Ark. It's been released a couple of days ago. It's an MMO, free to play. But I don't know what happened. Everyone is just like overloading the servers, so I could not connect. So that's weird. Like, people need something just to, I don't know, to have fun. They all went on this kind of server, so I cannot play anymore. But that's fine.
That's okay. Patience is a virtue. That being said,
I'm preparing a half marathon in Cambridge in 3 weeks.
Ooh, look at you!
Yeah, that's gonna be fun.
I mean, good
maybe not too fun for me, but for
yeah,
others.
That's good. That's good. It's good to be active. It's good to be active. That being said, let's keep things active. Remember, folks, get your questions in the chat. All right, get your questions in the chat. We also got the Slack channel open. DOK London, you can jump in there. If you're not familiar with our Slack, please jump in. We're happy to get you onboarded there as well. But remember, take advantage of the session. We have two wonderful folks that are used to doing these kinds of things. So please, please, please get your questions out in the open. You do not need to wait until the end. Do not feel like you need to do that. All right. Get these things out there in the open. They're supposed to be interactive. It's not supposed to be a monologue. That being said, I'm going to go to the backstage. I'm going to let you two take it away. And I will be joining later for the DevRel panel. So we'll be seeing you soon.
All right. Thank you. Thank you for a lovely introduction. It was very funny because Nick said like, I don't have much secrets, but I do have a lot of secrets, and this is exactly what I'm going to be talking about right now because Vault does things with secrets. So yeah, as I said, my name is Dominique, and I am a solutions engineer at HashiCorp. For those of you who do not know us, HashiCorp is a software company that focuses on cloud infrastructure automation. We provide a software stack that enables organizations to provision, secure, connect, and run any app on any infrastructure, be it on-prem or in the cloud. You might know us from products like Terraform, Consul, Nomad, Vagrant, and Packer. We've got loads of other things, Boundary and Waypoints. I can name all of them, but today I'm just going to give you a brief overview about what Vault is, because that's what we'll be using in the hands-on lab later. So this is a very, very, very brief presentation because Vault is so large. It's I can talk about features forever, but we're going to be using some of Vault today, and I'm going to just give you a bit of an overview. So what is Vault? Vault is an API-driven, cloud-agnostic secrets management platform, which allows you to securely access, store, and manage secrets in hybrid, multi-cloud, and multi-data center environments. That's the marketing tagline. Basically, what that means is Vault is a security appliance, which is designed to improve on security postures within any organization. The three main use cases for Vault are secrets management, to centrally store, access, and distribute dynamic secrets, keeping your application data secure with centralized key management and simple APIs for data encryption, and advanced data protection, which enables you to integrate with stuff like KMIP and HSMs and stuff like that. So, a couple of features that I want to run through. All should be moderately in line with what we'll be doing later on. Vault is designed to be pluggable, and comes with various components called secrets engines and authentication methods. These are pretty much the main two things that you use when you use Vault. This allows you to integrate with internal and external systems. The purpose of these components is to manage and protect your secrets in dynamic infrastructure, like database credentials, passwords, or API keys, and you can easily revoke them in case there's a breach. Authentication in Vault is the process by which user or machine supplied information is verified against an internal or external system. Before a client can actually interact with Vault, it has to authenticate against an auth method. And when it's actually authenticated, then Vault will generate you a token. Auth methods are the components in Vault that perform authentication and are responsible for assigning identity and a set of policies to a user, kind of how you might, present an like a valid ID at a hotel reception before you get the hotel room key. So basically, users and applications will have to provide some sort of credential or token to authenticate. You can have multiple authentication methods. You can have multiple auth methods at the same time. You can have multiple instances of the same one as well. Basically, you can use any of that to make sure that it works for your use cases. Okay, secrets engines are the other part that is the pluggable part of Vault. Secrets engines are the components which store, generate, or encrypt data. Secrets engines are really flexible, so it's easiest to think about them in terms of their function. Secrets engines are provided some set of data, they take some action on that data, and then they return a result. Some secrets engines simply store and read data, like the key value secrets engine. There are also databases that connect to other services like cloud providers and databases, generate dynamic credentials with the time to live on the fly. And then there are other secret engines like the transit and transform secrets engines that provide you with encryption as a service, TOTP generation, certificates, and much more. Secrets engines are enabled at a path in Vault. So when a request comes to Vault, that router automatically routes anything with the same prefix to the secrets engine. This way, each secrets engine defines its own paths and properties. To the user, secrets engines might come across like a file system or a virtual file system supporting operations like read, write, and delete. So in today's lab, we'll be using the transit secrets engine, which is what integrates with Trousseau, which we'll be hearing about more from Nick later on. So what does the transit secret engine actually do? So it does a bunch of different things. It basically handles cryptographic functions on data in transit. Says kind of like what's in the name, right? It could also kind of be viewed as cryptography as a service or encryption as a service. So the transit secrets engine can also sign and verify data, it can generate hashes and HMACs of data, and can act as a source of random bytes. So the primary use case for transit is to encrypt data from applications while still storing that encrypted data in some primary data store. This relieves the burden of the proper encryption and decryption from application developers and pushes that burden onto the operators of Vault, which basically means that you do not have to be a cryptography expert to still leverage the encryption and decryption by modern security standards. So before I did anything with Vault, I'm not a cryptography expert, so using Vault makes it a little bit easier to still adhere to the latest standards. Okay, last slide, I think, is the last slide. Yeah, so lastly, it's good to know that Vault comes in a couple of different flavors. All of our software is available open source, which you can install pretty much on any OS. It ships as a single binary. Vault open source is particularly great for individual practitioners to get started, but we have commercial offerings, enterprise offerings for to enable more collaboration and scale. So since a year ago, we also offer Vault as a SaaS solution, but let me just not go too much into the details. But if you have any questions about any of this, please feel free to drop me an email on Dominique@HashiCorp.com or at DevOpsDommy if you want to follow me on Twitter or something like that. So yeah, if you have any questions, I'll be on the Slack. I will be on the comments portion, I believe. I'll also be in the panel and helping out with the workshop. So with that, I would love to hand it over to Nick.
Thank you, Dummy. That was great. So what I'm going to do, I'm just going to remove this from live. And you too, I have to remove you. I I don't want to do that, but I
Are you
will have
okay?
to.
I'll be
Yeah, you be
backstage.
okay?
It's
So,
okay.
yeah. Thank you, Dummy. So what I'm going to be covering what we are going to do today. But before that, I just want to repeat what Bart said before regarding the swag. So the first 10 delegates to finish the lab will get Ondat hoodie, which is very nice, and some HashiCorp swag. So what we need for that, just take a screenshot of the lab finish. You will see when you finish the lab, you will have some feedback requests, and with a little smiley if you are happy or not. Hopefully you're going to be happy with the lab. Just take a screenshot, post it on the Slack channel, and then that's fine. And then out of these 10 delegates who finish the first, you will enter a draw for winning a Ondat North Face bag, really good quality bag. And the only condition for that, so you just post something on, just flag the lab on Twitter with DOK community in copy, or Ondat IO in copy, or HashiCorp in copy. Also, by now, I hope everyone on the live stream has already joined the Slack channel, where people will, and colleagues of mine will help you with the lab should you have any issue. What else? And then, yeah, for the next DOK London, that will happen but I will repeat it at the end, on the 24th of March. That will be, hopefully, cross finger, in person in London with pizza and beer, hopefully, and maybe some songs. I know Bart may be there, so he can rap. Richa from Ondat can also sing, and maybe Dummy, she will come and sing as well. I'm not sure. We'll see. All right. So with that being said, let me share this screen, and let's get started with my part. So before going to the lab, I'm just going to be talking quickly about what we are going to do today. The topic for the day is, of course, secrets, but also Kubernetes API server and how it handles encryption. So first of all, when you deploy and you develop application in Kubernetes, there are different ways to store application data. When I'm talking about application data, it's not only like a database or something like that. Any information that is useful for the application to run. So any context information, environment variables, all these kind of things. So there's different way to store this in Kubernetes. First, we have, let's start with the lower right. So we have volumes. So typically volumes under the form of PVC or a persistent volume claim, what they do is they provide you with a way to mount disk space into your container, and you can store things there. So that's one way to store data in Kubernetes. Another one is config maps. So config maps is basically key value pairs you put into a Kubernetes object, and then when you deploy a pod, the pod can consume these resources, and then you can just inject the config map as a file, as an environment variable, all these kind of things. But it's a first-class citizen within Kubernetes. You also have what we call the downward API. So the downward API is this ability of Kubernetes. When you have a pod manifest, you can refer to elements of Kubernetes for the application. So you have specific fields that you can inject into the container that Kubernetes knows about. So for example, if for whatever reason you need the pod IP and inject it somewhere in the pod to begin with, then this is something you can do by referencing this particular status pod IP or something within the Kubernetes manifest directly. So it's a way to infer information from Kubernetes directly into the pod by using Kubernetes knowledge, right? Or Kubernetes downward API, using Kubernetes API itself. That's another way to do it. It doesn't work with all the fields, so you have to go into the documentation and check what you can do with this. And last but not least, secrets, which on paper really looks like config maps, except that it's a different object. So typically it's used for a different purpose, which is storing more sensitive credential. And the main difference here, when you look at the object itself, well, there's on the left, you have config map, so you can see everything in clear text. And on the right, you can check, you can see secret, and you can say, okay, it's encrypted, but actually, no, it's not encrypted. This part here that I've highlighted is considered clear text. Why? Because it's just base 64 encoded, right? That's basically it. So if you were to take this part, what is inside the red rectangle, and just use base 64 decode, all that line, that what you will see is exactly the same content as what you see inside the config map. So you're like, okay, wait a sec. So it's a secret, and it's not really a secret, because anyone with who can decode base 64 can have access to that particular secret. But why should you care to begin with? So as I was saying, typically secrets are supposed to be used to store more sensitive information that you don't want to share with anyone. Typically, it can be your AWS keys, your API keys, things that you don't want anyone else to see, or not people who don't have the right permission to do that. So here's the challenge with Kubernetes. Knowing this, what happens to secrets inside Kubernetes if you don't encrypt them? So any user with read permission for secrets, right, on a particular namespace will be able to read all secrets given a particular namespace. So although it's still, namespace, anyone with, permissions to read secrets will be able to read any secrets within that namespace. Then also, Kubernetes doesn't encrypt anything in etcd. And as you know, hopefully you know that, Kubernetes store all the objects, all the information about the objects within etcd, which is the key value store used by Kubernetes by default. So anyone with read permission for etcd, which typically means that you are root on the control plane nodes, can read all secrets in the cluster. So there's no granularity. If you have access to etcd in read mode, then you can see all secrets that are present within the cluster, which is also not really good. Another one is that anyone who connects to a pod, right? So you deploy a pod, the pod itself always mounts a service account, with information like the default service account that is created into the namespace. So you spin up a pod, by default, always service account attached to it. So by default, this service account cannot do anything. But if at some point someone, enable read permission for secrets for that service account, there is consequences outside of Kubernetes, because now, as this secret is mounted within the pod, it means that anyone who has read access in the pod, right, not even in Kubernetes, who can, I don't know, maybe SSH into the pod, or just get inside the pod. If you go into the right directory, you will see the secrets as unencrypted, right? So those are pretty difficult challenges, and any enterprise who deploy Kubernetes in production will face them, because what I've mentioned is mandatory for a security, a CISO or someone with this kind of qualification. This is mandatory to mitigate, right? So how to do it? So first of all, apply the least privilege principle. Only allow users in Kubernetes to get access to what they need. I know it can be complicated because you can go very granular. By default, everything is open. But I would take the opposite approach. Start with no one can do, nothing. And then if people need to do something, then granularly give them more permission, not the opposite. At least for production cluster. For test, may be different. But still, remember, even in a test cluster, protect your secrets. Otherwise, anyone, we fall into the trap I've mentioned before. If anyone can access your AWS credential, then don't be surprised if the day after you find like a lot of mining, people mining Bitcoins, right? So it's not ideal. A second one, which we're going to be focusing today, is encrypt secrets at rest in etcd. It doesn't solve everything I've mentioned before. It's basically solve the one where if you have access to etcd, then the secret will be encrypted there. If you mount the secret in the pod, still visible. It doesn't solve the secrets when it's directly accessible from within the cluster. It solves for the problem where people can get access to etcd, whether it's a backup or something, because typically you will do backup or snapshot of etcd, which means it's going to be somewhere on a disk with that data. So, and you don't want that data to be visible by anyone who can have access to etcd backup. That's pretty bad. Another one, it's secure etcd members communication using TLS, but this one is rather, it's just logic, right? Anything you do inside Kubernetes, always enable TLS. And by the way, in the lab, it's not enabled. So I'm just contradicting myself because it's not enabled for the lab. But yeah, it's just a lab, right? And in terms of who can get access to etcd, typically you just want to enable the Kubernetes API nodes to get access to etcd, no one else. So advice is just use basic, ACL, firewall rules, anything you can think of in terms of stateful firewall rules is also good. Right? Okay, so now let's focus on the encryption part and how we will do it with Trousseau. So first, what is Trousseau? So Trousseau is a standardization KMS plugin that allows you to integrate with external KMS provider and offload the management of secrets, encryption, decryption to an external KMS provider. And today we're going to see the integration with Vault, which is the only one we have for the moment with Trousseau. But as the project matures, we will have other integration with other KMS provider. Should it be cloud KMS provider or from other vendor? So how does that work? So the API server has an option to encrypt etcd, but what Kubernetes defines is pretty high level. Basically, it tells you, okay, I'm going to send you a request to encrypt the traffic and to decrypt the traffic. And that's it. This is what Kubernetes assumes. It's just, I'm going to send you a request. I'm expecting something back. If it's encryption request, I'm expecting like encrypted payload. If it's decrypts my secrets, then it will be, the assumption is that it should return the decrypted secret. It's not only available for secrets, meaning that you can, if you want, you can encrypt any resource in Kubernetes that is stored into etcd. But again, here we're talking about encrypting what is stored in etcd. Right? I want to insist on that. It's not encrypting anything else. We send the API, the request to the KMS plugin, in our case, Trousseau. So the user basically create the secret.yaml, the secret you want to create in Kubernetes. You send it to the Kube API server. The Kube API server will then see, do I have encryption enabled? Yes, no. If yes, where is the socket I should write to, like gRPC communication? So it's going to send the request there. And hopefully on the other side, you have the KMS plugin, so Trousseau, the gRPC server, which is listening for those requests. And it's going to say, this is an encryption request from the Kube API server. Okay, I'm using with the configuration file from Trousseau. The system is going to see, okay, this is votes I'm using in the backend for that particular set of secrets I need to encrypt for that particular cluster. Then I'm going to send it to Vault, and this is where we translate the high-level encryption request into a low-level KMS provider specific request, in that case, Vault. So what's going to happen, Trousseau is going to ask the transit secrets engine, please encrypt. So remember, Domi said it's encryption and decryption on request, meaning that Vault won't store the data, right? Vault store the keys used to encrypt and decrypt the secrets, right? So no data stored there. The only thing Vault will send back the encrypted key. Trousseau then will tell the API server, here's what you asked for, and the Kube API server will then write the encrypted data into the etcd database, right? And if you need to decrypt, it's the opposite that will happen, right? So Kube API server, when someone is trying to, just access the, if you need to access the Kube API server needs to access the data, it will send decrypt request to Trousseau to Vault, and then back to the Kube API server, and then the data will be decrypted there. So meaning that again, it's the encryption is in Vault. So if you do kubectl, if you have the permission to read secrets, with kubectl get secret -o YAML, it will still be unencrypted. Okay, I'm just checking if there is questions there. Don't hesitate to ask questions as we go. Okay, there's a lot of things happening around, discussion around pizza swag. Yeah, it's probably the most important part. I understand, I get it. But yeah, as we go, if you have any question, yeah, feel free to ask anytime. So what time is it? 30. Oh, we went too far. Anyway, so before going into the lab, I will do it with you, right? So the link for the lab, I will give it just in 1 sec. Hopefully, is it in the chat? I'm not sure if the link to the lab is in the chat. No, there's a link to the meetup in the chat. If you go there, it will be there as well. Anyway, so first task in the lab, there are 3 challenges. The first one is going to be like, get familiar with Vault, encrypt, decrypt messages with the transit secrets engine. So not real Kubernetes so far. I mean, Vault is deployed as a Kubernetes stateful set in the lab. So still related to Kubernetes. Then the second challenge will be to deploy the Kubernetes KMS plugin, so Trousseau, and connect it to Vault, check that everything is fine. And then also make sure that the encryption is enabled on the API server and enable this. Then encrypt secrets in etcd. And the last part, which is probably the most interesting, again, about stateful application. This is the OK, we work on data. This is our main focus. And we'll be deploying a MongoDB cluster, 3-node, with the community operator, and we'll encrypt persistent volumes themselves. So it's another level. We were talking about encrypted secrets. Here we're going to be encrypting persistent volumes, and by using a storage class, which happens to be Ondat in that case. And the way this is going to be done, the volume are going to be encrypted using private keys. So 1 set of keys per volume. So we're going to be working with this and make sure that the private key used to encrypt the persistent volume, they are stored as secret, and we'll make sure that this secret is really secret and is basically encrypted. Okay, so the lab is there. I'm going to copy paste this into YouTube channel. There you go. That's fine. So we have normally about 20 labs ready. Even if there are more people, is the only difference. So click start track already, right? It should be fast because there are hot start labs. If there are more than 20 lab consumed, then it's going to take maybe a bit more time, like 4 minutes. But here it should take 1 minute maximum, one minute to get the lab ready. So again, the link is now in YouTube channel. If you don't have the link, you can also go on the meetup page. You will see in the description here. So there are a couple of information, the DOK community Slack channel, and also the link to the Instruct Lab is there. Okay, so still waiting for the challenge to start. Meanwhile, I'm just checking if there is no question. No question so far. So still setting up the challenge, there will be like a couple of points where, like a transition where it may take a bit of time to just to take, like when we're going to be creating the database for the stateful set, the stateful set to be spin up. Okay, start. But I'm going to go, with you, so you can follow along. I will read everything. I will do everything at the same time as you. So be just aware. I can see like what's happening on YouTube now. There's a bit of, shift. There's a bit of delay between when I'm, what I'm saying and the moment you hear it. So again, if you have any question about the lab, there are people on Slack there to help you. So you can ask a question there. Or, if you want to do it fast, you can do fast. Remember, because the first 10 people will get the swag. So you can go fast and not wait for me. If you're not super familiar with, Kubernetes or not comfortable with all this concept, you can just follow along. All the instruction should be sufficient for you to do the entire lab. Explanation should be comprehensive. There shouldn't be any problem with it. So I'm going to start. So hopefully you had time to click on start the lab, but I'm going to go slowly at the beginning so you can also catch up if it's taking a little bit more time. So let's read this. Right? By completing this challenge, you will familiarize yourself with Vault operations in Kubernetes. So Vault is an identity-based secrets and encryption management system. And a secret is anything that you want to tightly control access to, API encryption keys, password, or certificate. And Vault provides encryption services that are gated by authentication and authorization methods. So secret agents, again, they are components which store, generate, or encrypt data. They are flexible. It's easier to think about them in terms of function. And secret engines are provided some set of data. They take some action on that data and then return a result. Basically, I'm paraphrasing what Dominique already said. So there's a lot of secret engine available in Vault. By default, nothing is enabled, just the cubbyhole. So the first thing we're going to have to do is enable that particular transit secrets engine and just check that it is providing encryption and decryption services. I didn't mention, but why do we need Trousseau in the first place? Because, as I said, Kubernetes can rely on external system, or has to rely on external system to encrypt the data. But the problem is that there's no standard to do it. So if, for example, if you look at Vault today, it's not using the Kubernetes pattern, the standard pattern to do it, which is what I mentioned. Through the API server, you encrypt your secrets into etcd. A lot of different vendors that provide a different pattern. So Vault, HashiCorp Vault has a different pattern by default, where Vault will be injecting a sidecar agent that renders Vault secret to shared memory volume, or you can use the Vault CSI driver to mount secrets into the pod's volume. There's no involvement in terms of Kubernetes or the API server, right? But this is where Trousseau comes into play. Imagine that you may be using more than one KMS. You may be using a cloud KMS for your GKE cluster. You may be using Vault for your another cluster on-prem, or your Rancher cluster. And you end up with different solution, with different mechanism. There's no standardization. So what Trousseau will allow you to do is to connect any backend KMS provider that we will support over time, but without changing the integration layer. The KMS plugin will stay Trousseau. What you change is just the backend KMS provider. There's no need to re-implement the logic and the code every time, right? Because if you rely on vendor, on KMS solution, they would have to do the what Trousseau does in a standard fashion. They would have to implement it in their specific way every time for every vendor. So it's not something that is that provide value for vendors or for Kubernetes. And I guess this is why this was kind of a gray area. And Trousseau is basically the only solution that you can find, standardized solution that you can find today. You can develop your own if you want, but here the idea is to create these open source projects so people can contribute and support as many providers as we want, right? So here, as I said, we take a different approach by using the Kubernetes standard pattern to encrypt resources in etcd. So can encrypt secrets, but other resources as well if you want to, but more importantly, secret, because this is what you want to keep secret. Makes sense. So the goal is to store encrypted secrets in etcd while keeping the encryption key management outside the cluster. And Vault is basically acting as a bump in the wire, providing Kubernetes secrets encryption and decryption services on demand when the Kubernetes API server needs it. And this is, what I said, Trousseau is what makes it possible. It's a KMS plugin that translates high-level requests from the Kubernetes API server into more specific Vault operations. It leverages the Vault Transit Secrets engine to encrypt and decrypt secrets on demand on behalf on the API server, which is connected to Trousseau through a gRPC channel. So again, here, this is what I've mentioned with the workflow. Create a secret, Kube API server calls Trousseau. Trousseau sends the encryption request to the KMS provider. KMS provider returns encrypted data to Trousseau. Then Trousseau sends the encrypted data back to the Kube API server, and Kube API server stores the encrypted resource in etcd. All right, so hopefully by reading through that, it gives you some time to get the lab ready. Hopefully everyone found the Instruct lab. Okay. It should be fine. Just reading through the comment quickly. Yeah, it doesn't seem too many problems. Okay, so let's start with the real stuff. First task. So you will see there's a lot of verification commands, and there are some configuration as well. So hopefully you shouldn't be able to mess it up, at least in the first challenge. Later, I'm going to point you, I'm going to highlight specific tasks where you will have to be careful about things like indent in YAML, because YAML is not going to forgive you, right? That's the problem. Okay, so in the context of this lab, Vault is deployed in the same Kubernetes cluster as the secret it manages. This is a critical flow. There is a critical flow with this architecture, obviously. Vault and the cluster share the same fate. So a couple of scenarios would lead to the whole cluster going down or being compromised. If some part of the cluster, in case of the cluster failure, the Vault stateful set can be impacted, so can be down actually. But the problem is that if the Vault pod is down, you cannot decrypt secrets, right? So you see, it's like a chicken and egg issue. So it's a bad idea. And also, it's in case of in case the cluster is compromised, the Vault backend storage, which is hosted here in the same cluster, it would be directly accessible by the attacker, including the keys and everything. So not ideal for production, but it's the simplest way to get started. It's a lab. Don't do this at home. Don't do this in production. The best way to do it, you can have Vault integrated into or deployed in another cluster or as virtual machine in the cloud, or you can use the SaaS services or PaaS, HashiCorp on the HashiCorp cloud platform, right? You can also use Vault there as a service. So today, here, we also, the Vault is deployed in Kubernetes as a stateful set, and also you have the sidecar injector agent. We won't be using, as I said, the sidecar injector agent because we are going to leverage the Kubernetes native encryption capabilities. Instead, we will directly use Vault Transit Secrets engine. So in this lab, Vault is scaled to a single stateful set replica. So you will see it's called Vault-0. And as stateful sets provide a stable identity, the corresponding pod will always be named Vault-0. That's a property of a stateful set, stable network identity. In a production environment, of course, you would scale the Vault stateful sets to multiple replicas. So you have a Vault cluster. So, just check out the HashiCorp documentation on how to do that. If you want, they have A lot of also tutorials, labs, learn.hashicorp.com is great for that. So when installing Vault, the Helm chart, so it's installed with Helm, it's probably the safest and simplest way to install it. Make sure a PVC is created, and this ensures that the data persists in case the pod is restarted. So first task is just check the stateful set configuration. Here is just some parsing of the current lab, of the current configuration of Vault. So a couple of things that are highlighted there. Here we have highlighted a couple of important details. So it's a stateful set, therefore it needs headless service. I'm not going to explain too much what is a headless service, but basically it's a service without a cluster IP so that you can directly access a particular pod, for example, part of the stateful set. So Kubernetes provides a built-in DNS service that resolves the headless service name to the list of Vault pods IP. In our case, we only have one, right? So another important thing is the port on which Vault listens. So it's 8000, 8200, 8001, 8201, 8202. So we are mostly interested in port 8000, 8200. My God, I've got, it's like when it's not your native language, numbers is always difficult. It's crazy. Anyway, 8200, which listens for HTTP requests. And this is the port used by Vault client. And the pod has multiple mount points. You will see under the PVC, there is the Vault config, which is a config map, and there is /home/Vault, which is attached to just a temporary directory. So let's also check the pod Vault 0 is running and that the PVC is bound. This is quite important. If it's not bound, it won't work. Okay, here you go. It's running. It should be running for you as well. The PVC, here you can see that it is bound, and we have the PVC ID there. So at the moment, everything is working. So you can notice there, local path is used. It's a CSI-specific storage class, I would say, that consume unencrypted local volumes from the underlying node, right? So here again, if you're in production, this may not be what you want to use. You may be using another CSI that provides more capabilities. Okay, so now that we have verified this, as we are preparing to deploy Trousseau, we need to create effectively the transit key in Vault. So this key will later be used to encrypt and decrypt secrets on demand. But before creating the transit key, we need to enable the secrets engine by using the following command. So what it does is just running Vault secrets enable transit inside the Vault pod. You can see here Vault-0. This is the name of the pod. So if I do that, I should be having this. So success enable the transit secret engine. Okay, so this one is fine. Now, second step, or before reaching this, let me check if there are any questions. Okay, no, nothing. So far, so good. Okay, so now let's execute the next command that will allow us to create the transit key. So be careful on about that one. I think there's a warning here. Make sure to use Vault KMS demo as the key name, right? So this is the name of the key is the last part, excuse me, in the path. So Vault-KMS-demo, because this is the key we are going to refer within Trousseau, right? So when you have done that, success, data written, everyone is happy, and that should be fine. So next step, this engine provides on-demand encryption services. That is, it provides encryption APIs for clients without storing data. So now we're going to try that we have created the key. We're going to try to encrypt a key, a message with that key. So there's the command for this, which I'm going to explain quickly. So in Vault, you have to specify the path. So you can see here transit/encrypt means that I want to encrypt. This is the action, the API path, right? So I want to encrypt using Vault-KMS-demo and plain text. But again, this has to be base64 encoded. So I'm just encoding here the content of my message, which is, I know what you did last summer. Be careful. So the reason for this requirement is that VOD does not require that the plain text is text. It could be a binary file, such as a PDF or image, not only text, right? And of course, the easiest and safest transport mechanism to transport data, if it's not text, over the wire, is by encoding your data with base 64, right? So that you don't have any weird character all over the place. Here it's guaranteed you have Unicode, right? So here we go. Now, as a result, here you have the ciphertext that is returned. This is the data that has been encrypted. So again, this data is not stored in VOD. Actually, it's not stored anywhere at this stage, right? So now we want to see that we want to decrypt that message now again, right? So for that, let's decrypt the message, which is the opposite operation. Again, I'm going to quickly explain what it does. So I'm running, again, a command from Kubernetes directly into the pod, the VOD pod. So I'm going to write this time, not at the encrypt location, but at the decrypt path location, because this is the action I want to do. Still specifying the encryption key I want to use. And this time I have to use the particular ciphertext. Of course, the ciphertext is not the same as in the guide. So you have to replace that one, right? So for this, I'm just going to replace this, or Control W, that works too. Ciphertext equal, and then you have to take all of that, paste. Here you go, plain text, and now copy this and base 64 decode here. Here you go. So without doing anything, I'm not running an encryption myself. I'm just using VOD as a service to encrypt and decrypt my message. So typically, this is what Kubernetes will use, right? The difference is that Trousseau now is going to perform those tasks on behalf of the Kubernetes API server when the API server wants to encrypt secrets and store them into etcd. Okay, so we are done for that particular task. Once you're done with this, you can just click on check to continue, and you will have a script that will check if the task has been done before moving to the next challenge. In the meantime, just checking if there's no questions. So hopefully, if all the 23 people watching are doing the lab, that would be awesome. But no, that doesn't count because I know there are marketing people. They won't do the lab, I'm sure. Okay, let's go for the next one. So now that you have prepared VOD for encryption as a service, let's deal with the Kubernetes API server to enable encryption and configure Trousseau as the KMS plugin. Get ready now. Okay. So this is where it gets a little bit more complicated, but I've done almost all the work for you. You will just have to edit files, save, and that's it. But again, I will make sure you don't make any mistakes. So I'm going to highlight the sensitive parts. So in this challenge, you're going to configure Kubernetes to enable etcd encryption, deploy Trousseau in the cluster, and use it to encrypt secrets with the VOD transit key. So the workflow for this challenge is that one. You're going to create Trousseau configuration file. Then we're going to deploy Trousseau as a static pod on every node, part of the control plane. For people who don't know what a static pod is, it just means that instead of having the regular pod or replica set controller that spin up the pod, it's the manifest is defined within a particular directory on the control plane nodes. And as soon as you place the manifest there, the kubelet will make sure that the pod is run forever, right? So if you kill it, it will restart it, etc. So it's a pod that is directly managed by kubelet without having the regular controller. It's just, this is why it's static. It's because the manifest is directly placed into a special directory that kubelet monitors to run static pod. It's called a static pod, right? So, but actually, Trousseau also can use daemon set. So there's two ways of doing things. Static pod, which is like the old way, but in the meantime, we also change it if you want. You can use daemon set. And why you would use daemon set as opposed to static pod? Well, a couple of reasons, but probably the main one is with a static pod, you need access to the master nodes, to the control plane nodes, which you don't if you use GKE or AKS or any managed sort of server. This is where you need to use the daemon set. Okay, so then create Kubernetes encryption configuration file. This is to enable encryption on the Kubernetes API itself. Enable the Kubernetes encryption on the API server. Restart the API server. This one is automatic. So the API server expects, to enable encryption, expects a particular configuration file, a particular object that is called an encryption configuration. It's a first-class citizen in Kubernetes. It's a resource. And then at the end, you can optionally, we're going to see that because the challenge, or not the challenge, but the problem with enabling encryption, as you run your existing cluster, is that only new secrets will be encrypted. All the secrets that are already existing will still be presented as unencrypted in etcd. So if you want to replace at the same time all the secrets, there is a secret magic command that I'm going to show you that is actually in the lab that you can use to do that. So let's start with this one. So Trousseau is deployed as a static pod, as I was explaining. You have to store the Trousseau pod manifest in a local directory. This directory, typically by default, it's etc Kubernetes manifests. This is the source that is checked to deploy the static pods when kubelet starts. So let's just check that it's the case there. I'm not going to lie, I'm sure it's going to be the case. So you can see in the kubelet, so this is where you specify it. Right? It's also to tell you where is that setting. If you need to change it at some point, it's under varlib kubelet config.yaml. So here we can see we have this line which specifies where the manifests are. So let's now create the pod manifest. For this, we're going to navigate to the editor tab on top of the screen, which is here on the top, and open the file name vault-kms-provider.yaml under root Ondat Trousseau. All right, so you open this file, which is vault-kms-provider. Okay, so here you go. I'm just going to maybe do this a little bit. So you can just have a quick look at this file. It's a normal pod, definition, except it's just a static pod, but that's it. Not too much difference. So line 12, Trousseau and the Kubernetes node share the same network namespace, right? Trousseau expects line 22, this particular configuration file at this particular place, in our case. 23, remember I talked about the sockets that is used for all this gRPC communication back and forth. This is the sockets that is used. Path is there. Don't worry about the opt vote KMS. It's been already created. You don't have to create the directory. 3031, it runs as root on a read-only file system. Then 37, we have a health probe running on the container, meaning that if you have a problem with the backend KMS provider, Trousseau will always make sure that we can, that the health probe can talk to the health probe triggers a test that makes sure you can talk to the backend KMS provider. If you cannot, as usual in Kubernetes, health probe, after I think that's 3 failure, it will shut down the pod. And the pod will restart and try again, and until you get a loop of death, the crash loop back. But hopefully you should not have this problem today. So it's 3 failure with a period of a check every 10 seconds. Okay, what else? Trousseau mounts the directory opt vote KMS as a local volume within the pod on line 48 and 51. So this is why this directory is very important, because it's mounted directly into the container. So the only thing we have to modify in this file, as we are not using vote enterprise, we just have to remove this file here, this part here, which is highlighted. So where is it? Here we go, the end part, right? Just remove this part, careful. You can save in 2 ways. Control S, even if you're on Mac, don't use command, it's control. Control S works to save, or you can just click on the little floppy drive. So that's fine. Then the next step is to configure Trousseau itself. In the editor tab, open the file named config.yaml, right? This is where you need to replace the address with 3S, sorry about that, and replace the token. So IP address we need, and the token. To get the IP address, you have the 2 commands that are displayed there. So the first one there, go back to the console, paste this, you have the IP address, and as to the client token, you can get it using the following command. Again, copy, just click, it will copy directly, paste this, and this is the token. So go back to my editor, this is the IP address, remove HTTPS. Remember, I didn't implement TLS for this lab, which is bad. Don't do this in production, it's bad, very bad. Okay, and the token is that one. Okay, that should be fine. I can save, just double checking everything is okay. Double check, triple check, it's fine. So with this information in hand, edit config.yaml, which I just did, every student has a different token. So you have to run the command I've written there on the guide. And again, remember to use HTTP and not HTTPS, because otherwise that won't work. So now what we have to do is copy the config file to the place it is expected. So remember, it's in etc Kubernetes manifest. This is the vote KMS provider static pod configuration. I should not do this one first, sorry. I should follow the guide, don't do like me. I was like 1 step too fast. Copy first the config, because if you copy the pod manifest first, it will complain about the configuration not being reachable. You don't want to do that. So be careful. Copy first the configuration file under opt vote KMS. There you go. Let's go to the directory just to double check it's there. Okay, we have display it just to be sure. We have the IP address. We have the token there. It's fine. Now, second step, let's copy the static pod. This is where the challenge is, right? If you did something wrong, this is not going to work, right? I copy things there, and now I'm just watching the pod being provisioned. So here you can see we have now, for 7 seconds, we have vote KMS provider control plane pod that has been created. If everything is fine, under 30 seconds, you should not have any error message. If you have an issue with the backend vote communication, then you will see number of restarts is going to start growing, increasing because you have an error. At the same time, what you can do, you can also, if you want, display the logs, Kubernetes logs, then this F, sorry, I have to specify the namespace. The namespace is kube system, right? Kube system. Okay, so you can see here, I don't have any special error message. It's just checking every 10 seconds is running, completed health check. So far, so good. Just be careful the order where you copy the file, copy the config file first, and remove the S from HTTPS, put the IP address, the token. Those are the key steps for that one, right? Okay, so we have now Trousseau running. Trousseau can talk to Vault. Now we need to enable encryption inside, in the API server. So again, this is the tricky part, like editing live the kube API server configuration file, always a bit tricky. So the kube API server is also a static pod. So therefore, you also edit in the same place, in etc Kubernetes manifest, right? So we have to first, before changing the configuration file, remember, we need to provide an encryption configuration object. It's there for you as a reference. If you go under editor, you have it as well, right? So you have the files there, but you just copy it, right? You don't have to modify anything there. Just copy the file where it's expected under vote-kms, remember? Here. So now you should have those 3 files under, let me just do this. Oh my God. Here. So we have those 3 files, config.yaml, encryption _config.yaml, vote-kms, socket. You need to have those 3, right? Be sure to have this. Now, what it's setting up here in the encryption configuration is basically setting up the socket location, right? So now under the nested resources section, you specify the resources that will be encrypted. In this case, we are only encrypting secrets, but you can encrypt any Kubernetes resource. You can see it's actually a list, but today we only encrypt secrets. You can test with other objects if you want to. So what is particular to that file is the order of providers is important, because the first provider in that list will be used to encrypt resources you have defined just above. But you still need to keep the last one, which is by default needs to be there. It's called identity. It's just used for, to read unencrypted resources. So the problem is, if you don't include identity there, you won't be able to read an encrypted secret, right? Which means that, remember, at the beginning I said, it only encrypts new secrets. The existing secrets before setting up encryption on the Kubernetes API server, those secrets won't, the old secrets, existing ones, won't be encrypted. So therefore, if you remove identity from this file, you won't be able to read those secrets anymore. The API server won't be able to read those secrets anymore. That's a bit of an issue, right? So you keep it there, but not first, because again, if you make identity first in the provider, this is what is going to be used to encrypt, which means that there won't be any encryption. Right? Okay, I hope this is clear. Should be. So now, so this provider reads unencrypted resources. If it's not present, you won't be able to read secrets that have not been encrypted. Then open the file etc Kubernetes manifest kube API server under the static pod editor, right? So we have to go there, the static pod editor, which is just an editor into the special directory, etc Kubernetes manifest. Just use that one, kube API server. So again, be super careful. This is super sensitive, right? But again, just read through the instruction. So first, add the following lines under, the first is add the following line as a new command line parameter. So it's the last one, right? Command kube API server. Here you can see command kube API server there. Just copy the encryption here. Is it copy? Yeah. Just this line. Okay. This is fine. then the kube API server pod will need to access opt vote-kms. To make this possible, we also need to mount the directory opt vote-kms as a local volume, which means you need to add the following lines under volume mounts and volume sections, respectively. So again, let's find where that volume mounts is. It is a bit down there for the line. Volume mounts. Let's use this mount path here. Copy, paste. Here, be careful, indentation there. Just one tab, okay? Be careful. If you don't do it, that won't work. And second one is volumes. Same thing, we have to have the host path section, volumes, which is there, paste. Again, be careful, you have to indent one more here, right? So that it matches the others. Just check that it matches the other members of that list. And then click on the floppy or Control S and save it. As soon as you save, the kube API server is restarted. So don't save it. I should have said that in the beginning, maybe. Don't save it as you type. Wait to type the last portion or to insert the last portion before saving it. If you don't do that, it will fail. You will have to delete the file from etc Kubernetes manifest and recreate, when delete, move it to another directory, change it and move it back, right? Okay, so let's save it and cross finger. Okay, so now if the API server has been restarted, with the proper configuration, you should see a new flag, which is enabling encryption. And here you go, right? So now you can see with PS that we have the new flag that has been enabled. So effectively, it means that everything is working. It means that the kube API server is aware of the socket and can talk to it and therefore can encrypt secrets with it. So now it's up to you. Optionally, you can encrypt all secrets and just check later on if it's really encrypted, or you can keep them unencrypted so that you can see later on. I will provide, later in the lab, I provide a command to check inside etcd whether the secret is encrypted or not. So just to see the difference, you can keep the secrets unencrypted there or not. I won't, and just to show you how to encrypt all existing secret, just use this line. So you basically get secrets from all namespaces as JSON, as an output, and just replace them with themselves, right? It's just like I'm reading everything and I'm deleting everything and recreating everything, every secret at once, just using a single command line. Replace will delete the resource and recreate based on the inputs. And here the input is reading from the standard input, which is your screen, actually from the first command, redirecting into the standard input of kubectl. Okay, let's do that. We should see a lot of things happening now. Okay, so now I've basically replaced every single secret I have in my cluster with an encrypted version of it. Okay, so if you reach this step, congratulations. You have successfully enabled Kubernetes encryption with Trousseau and Vault. In the next challenge, you will explore database volume encryption with secrets that are really secrets. Yeah, click check to proceed to the next challenge. Again, it's going to take a couple of, it should be fine, I guess. Correct. The script is fast, but maybe to provision the next one will take a little bit of time, maybe 1-2 minutes. So in the meantime, is there any question? I get some failed get version from Nicolas. Okay, so I've got this question there. I'm getting some failed get version from remote KMS provider. Yeah, you have probably missed a step. Failed get version from KMS provider. So where do you get this? Can you post it maybe on Slack or YouTube? And yeah, okay, Chris is looking at this. Yeah, probably remember, yeah, HTTP, it has to be HTTP. HTTPS won't work. Trousseau works perfect. Yeah, let me display this. Good vibes. Your Trousseau just works perfect. Yeah, should be. Just be careful. Go as slow as you need. The lab is there for 1.5 hours, and it will be available after. Just go back on the same link, and the lab will be there forever. Okay, so we have here something else. We have opt vote KMS, no shots fired. I'm getting on Kube API server. Yeah, so you didn't copy the file there if it's not. Okay. Let's move to the next step. So now, challenge is ready. Final one. So in that particular challenge, after all this hard work, we'll see a practical application. So we will need to deploy a database, MongoDB database, encrypt the data volume with a key, and store this key encrypted in etcd using Trousseau and Vault. So I'm just going to repeat this to make it as clear as I can. We're going to deploy a database, MongoDB database, cluster of 3 nodes. All those nodes, they work with persistent volume claim. When I say nodes, I mean MongoDB nodes. All those containers, right? It's easier. All those containers will have a persistent volume claim. This persistent volume claim will claim persistent volume, and those persistent volumes are actual, disk space on your disks, right? So what we want is to encrypt these volumes. We want to encrypt these volumes outside of the container so that someone who has like raw access to the storage, to the volumes outside of the pod cannot read what's inside directly by mounting it, right? So to encrypt this volume, we need a key. This key will be stored in a secret. And guess what? That particular secret, typically, we want to encrypt it, because if we encrypt the volume and leave the encryption key for everyone to see, it doesn't make a lot of sense, right? We would agree, I guess. Therefore, we need to encrypt that secret. And because we have enabled already secret encryption, as we create the new secret, this secret will be directly encrypted using Vault and Trousseau, but we just want to verify this. Don't believe what people say, and don't believe what I say. Check it by yourself. Or maybe still believe what I say, but still check. Let's put it this way. All right, so the workflow for this challenge, we're going to deploy the MongoDB with the community operator. You will create a 3-node MongoDB cluster as a Kubernetes stateful set with 3 replica, because this is the OK. It's also an excuse to use stateful application and data, right? This is what we do here in this community. So create a new storage class that will enable volume encryption for MongoDB volumes. So it just happens to be Ondat, where just by using a new storage class that has encryption enabled, the storage class will guarantee that the volume would be encrypted. So it's super Kubernetes. You don't have to do anything. Just enable encryption in the storage class, as easy as that, right? So we want to keep it simple for this lab, and in general in production as well, as simple as possible, as Kubernetes as possible. So we're going to encrypt the data volume of the MongoDB nodes with private keys stored as secrets, as I said, and then we will verify that the data and the keys are both encrypted. Quick note, at the moment, you can examine, you can examine the content of the YAML file used in this challenge by navigating to the editor tab. So there's a brand new files directory that is there as when setting up the last challenge, and you can check everything. Don't modify anything, because actually there's no need. I don't think we'll go through it, but I don't believe you have to modify anything in file right now. But still, when I will use some script, I will go through it to explain to you what it does. So let's get started. Hopefully you can follow along again. So the local storage of your Kubernetes nodes is currently managed by Ondat, meaning that the free space is claimed by Ondat, if you like, meaning that if you use the storage class, Ondat will provision volumes directly on your local disks, right? So Ondat provides services such as data services such as encryption, replication, performance optimization, and you can enable encryption by adding a new parameter to the storage class definition. So let's create a new storage class with encryption enabled. So you can see here, just copy this and paste. This is just a here doc command. So the only thing you need to, we need to highlight a couple of things. File system type, XFS, this is what is recommended by Mongo rather than X4. So just change it here compared to like a traditional, more traditional, excuse me, storage class. And the name here of the storage class Ondat encrypted. And the only thing is encryption true. This is what enable volume encryption. That's it, right? As easy as that. kubectl get storage class. So if you want to use some, K instead of kubectl kg, I have some alias. I mean, you have some alias that are already configured for this lab. If you're more familiar with this way of doing things, so you can see I've got a new storage class that is called Ondat encrypted. Okay, first step done. Now, let's deploy the Mongo cluster. So go to /root/Ondat. I mean, you can copy paste it and apply the CRD. So first off, what we're going to do is, I'm not going to explain in details how operators work, but basically we're going to introduce a new Kubernetes extension, a new object schema that represents a MongoDB database. So this is all we do there. We just create this new schema so that Kubernetes can understand the new database configuration objects that you are going to send to the API server. So a couple of things we have to do with that particular operator. You can check the documentation, community operator on GitHub. Recently, you can also check on Medium. I've written a blog on how to do it. It's nothing different from there. It's just like a bit more explanation. So here, we want to deploy some RBAC resources that are required cluster-wide, so not namespaced. So yeah, don't miss any line here. Be careful. Again, every line is mandatory. Right? Then we're going to create a new namespace to host the MongoDB operator. So the operator will be used to act as a translation, right, between the YAML file and Kubernetes. So when a new CRD, a new custom resource will be sent to the API server, then the Mongo operator will recognize that and typically will provision the database as instructed by Kubernetes, right? So we create the namespace. So now we have to deploy the namespace RBAC resources here. And here, so be careful again, we need those RBAC deployed both in the Mongo operator and in the target namespace where the application, the stateful application will be deployed. So this is where MongoDB will be deployed. In our case, this is the default namespace. So next step, deploy the operator itself. Right? And just check that it's been deployed. Just watch this. You want to have the operator running. The moment you have the operator running, you're fine. It means that the next step is to create a database configuration. As soon as Kubernetes API will detect this, it will store this, and the controller will see that there is a new resource in the Kubernetes API, and we'll say, okay, I'm the operator, I'm responsible for this custom resource, And as an action, I'm going to deploy a new database cluster. Right? So this is what is left. Cross finger. While it's doing this, I'm going to go into the editor to show you MongoDB config, what we are doing here. Right? So in the database configuration, this is always a challenge with operator to understand what data you need to place, to inject into the YAML manifest. Every operator has different data because, of course, by default, CRD means custom resource definition. So by design is custom, which means that every operator will have its own way of doing things, of changing volumes, of enabling new user, creating new user, etc., etc. In the case of MongoDB, what we want to do is to use a PVC that is tied to the storage class where we have enable encryption, right? So here we need to change the storage class name because by default, the operator will use default of the storage class. We want to change this, right? Also, you may want to change the size, the name of the volume, etc., etc. What else we have here? I've created an admin user with a password. The password is hosted in a secret, but guess what? That secret now is encrypted, remember? Because we have enabled encryption. Here, it's not encrypted as a file, right? Remember, it's base 64. The password is Mongo. This is just the base 64 encoding of the string Mongo, right? That's basically it. So create a new user, which has like specific permissions, and that's basically it. It's not that difficult, but to find this kind of information, you have to spend time in the operator documentation. Usually you will find, use cases and examples, but not like a single example will perfectly match what you want to do. So you have to try out things and go little by little, what is working, what's not working. At least here, I know this part is working because I've tested it for you guys. So now let's check that we have our pod running. Okay, we have our MongoDB almost running. So while it's taking more time, guys, it's taking more time because it's not a deployment. This is a stateful set. Stateful application are using stateful sets. Again, stateful set mean that every pod is considered as a pet. Before it was called stateful set, it was called pet set. But yeah, probably stateful set is better anyway. So every container, every pod has a unique name, has a stable network identity, not the IP address. If I delete MongoDB 0, for example, what's going to happen? A new MongoDB 0 container will be created. The PVC will still be the same. The IP address will change, but the FQDN, the headless service, all that is still the same, right? And the name of the container. So the container doesn't lose its identity, or the pod, should I say, doesn't lose its identity when you delete the pod. It's getting recreated with the same number. If that was a deployment, then a new pod will be recreated with a different name and a random string at the end, essentially, right? So that's the main difference. Okay, so I've got my 3 nodes running. Just checking if there is no questions so far. No, everything seems to be okay. So now, where am I in the guide? So you will notice that pods part of a stateful set are created sequentially. This is by design, as every pod is unique and a new one cannot be deployed until the previous one is ready. So wait until all pods are running. Should take about 3 minutes. And yeah, Control-C to cancel the watch command. So now let's create a new database. So now that you have a running MongoDB cluster, let's create a database in a collection. A collection in MongoDB NoSQL architecture is exactly what a table is to a relational database. So you're going to create a JSON document in a database that we called Shakespeare, and the collection or the table, if that was a relational database, is called quotes. And we want to insert a new document, so typically unstructured or semi-structured document for DB specialist. So basically JSON data here, simple entry, publication is Romeo and Juliet. I'm a romantic, I can't help it. And text is what's in a name, that which we call a rose by any other word would smell as sweet. It's so nice. Anyway, so when deploying the stateful set, the operator creates a MongoDB replica set where one pod holds the primary data set and the other ones hold replicas. So let's first verify this by running this command. So the only thing I'm going to do in that command, I'm using MongoSH, which is present on every Mongo node. And then you want to, it can be any node at this stage. It can be MongoDB 0, 1, 2, 3, right? Doesn't really matter. And so MongoSH, I'm connecting to the database, username admin, password Mongo. And this is the command I'm sending. Print JSON replica set status. If I do that, I should see the current status of the cluster. So you should see all the members with one primary and two secondary, right? So it can happen that it's not MongoDB 0 that will be used as primary. Let's say on 10 times, it happened to me like 7 times where I had primary as 0, but sometime it's another one. Okay, so identify your master. In my case, it's easy. It's MongoDB 0. MongoDB 0 is primary. Okay, so now we're just going to run this command to create the database. And I'm just going to go through that file to show you what it does. MongoSH here. So I'm just connecting to the database. Use Shakespeare means that you create a new database called Shakespeare. DB create collection quotes. I mean, self-explanatory. It's creating a quotes collection. And then insert one is the method to insert an entry in that particular collection, which is exactly the JSON payload I showed you before with the publication and the text, right? This is just what I'm doing here. And if it works fine, then you should see OK there, acknowledge true, and you should return an object ID, right? You should have the object ID return. And to check that it's there, oops, I clicked on something. Okay. To check that it's there, you can use this script. So again, I'm going to be running that particular script. So what is in that one? Check mongo.sh, which is there. So I'm just trying to listing the content of the collection that is called quotes and just display it a bit more, prettier. So I should see the result here. I should see the publication and the text, right? So if it works, perfectly fine. So now the only thing that is left is to check that encryption is enabled and that the text we are looking at is not searchable within the volume. So for this, we're going to do a couple of things. So first, I'm going to enable the StorageOS CLI or the Ondat CLI, which allows us to see on what host the volume is effectively attached. And it should give you like the list here of all volumes. And we will need to map this out to the existing PVC, right? So when you do this, you see that pick one MongoDB data volume that you want. Let's go through the text first. Like first, let's find the Ondat volume associated with the MongoDB pods by executing the following commands. Get the list of PVCs to map them out to the Ondat volume displayed above. So in this example above here, you can see that MongoDB data volume PVC ID is ending with 9B2, right? So let's check in my case now in the lab. You can pick whatever you want, like the node that you want, probably just pick the first MongoDB 0. You can see that the PVC ID is ending by AE4, right? AE4. So now what you want to do is find the same name for the list of volumes of Ondat volumes there that's finished by the same ID, AE4, and you want to see on which node it is currently attached. So you have to use the attach on column to see where the volume is currently attached. Is where, I mean, usually it's the same, but Ondat provides the ability to access volume remotely, even though the pod still thinks it's local. This is why you have a distinction between the location and where the volume is attached, right? But long story short, you need to check the worker on their attach on column. Usually it's the same, but for example, it can vary, right? Like this one is not the same. So here again, we check the ID, AE4, we check the ID, AE4, it's attached on worker 2, right? So here, you can choose any other MongoDB pod if you fancy. The data is replicated to the other 2 nodes. Just make sure you target the right Kubernetes worker node, right? All the commands I've done before, like the the database commands, this is supposed to be done on the master, right? This is why I told you identify which one is the primary, not master, primary. So, but before showing you that you cannot look for the string within the volume, let's check that within the pod, meaning that it's unencrypted, we can look for that particular string, right? So I want to check that within the pod, MongoDB-0, there is match for rows. You can see here, we have a match for that strings in the binary file, right? That means it on disk, I mean, from within the pod, it's not encrypted, right? And luckily, otherwise we would have problems. So you can notice that there's a match with multiple files. Now let's verify that the data is encrypted when accessing the raw volume. This is simulating an attacker who leveraged privilege escalation to get access to the storage device. The string rows should not be visible when the attacker tries to access the encrypted data. So let's verify this. Connect to the node where the Ondat volumes is attached to. In our case, this is node 3 in the initial lab, but in the current lab that I'm running now, remember, it's worker 2, right? So here you copy paste, and on worker 2, the data is attached there. I should not be able to see this. So I should return nothing. Nothing is returned. This means it's encrypted. But now you can say, yeah, maybe it's not there by default anyway, right? Maybe it's still not encrypted. Why do I know? Again, proof. So we're going to check with a pod that mounts a volume that is not encrypted with the same principle. We're going to put a string, still Shakespeare, into the volume and check that the volume, you can look for the string within the volume doing the same operation, and that is not encrypted. So for that, there is a pod that is ready. It's called Amlet Unencrypted. You're just going to create it. If you want to see the definition, again, it is there. The only thing I'm writing a command, so my words fly up, my thoughts remain below. Words without thoughts never to heaven go. This is so beautiful. Anyway, so this is going to be written in that volume, and we see that the storage class we use, where is it, is called storage OS, right? This is the initial storage class, which is not encrypted, right? So storage class -o YAML, and we want storage OS. You can see we don't have encryption enabled there, right? Which means it's false by default. So wait a little bit for the pod to be created. we should also see a new PVC. You can see the new PVC is there. It is bound. We should also see a new pod, the Hamlet pod, an unencrypted one is there. So we have to do the same work again, right? So you have the PVC ID that is there. So remember that one. I'm just going to copy the last part of it. And we have to identify from the storage OS command where it's attached to, right? So this is this line. Just copying the last part. Okay, so it's attached on worker 2 as well, right? So now, if I do the same command here, what I should see is I've got a match from the device directly. So here what I'm doing is from the host itself, from the worker host, not from the container, I'm trying to access the raw data, right? Here you go. So here I have a match, right? Which means that this one is effectively unencrypted. And hopefully we've got now the proof that the first one is encrypted and that one is unencrypted. And now the last step we have is to check that the keys are used to encrypt the volumes are also encrypted. So for that, we're going to get, it's a secret, right? So we're going to display the secrets that are there, the volume key secrets. So we're going to take like the first one as an example. And here, I'm just going to do that. I'm going to display the content of this. So again, get secrets. This part is totally unencrypted, right? It's encrypted in etcd, not when you run kubectl as an authorized and user that has the permission to do so, right? Okay, so as expected, the secret object is readable using kubectl and correctly decrypted by kube API server. Now let's verify it is encrypted within etcd. For this, we need to use etcdctl directly, which is the command line interface for etcd. So execute the following instruction, replacing the secret name following /registry secrets default, right? So just the last part of this command, you will have to replace it. I will do it with you. So this is the last portion of the path, right? Has to match one of those secrets, right? So why we have that many? So if you count, there is 1, 2, 3, 4, 5, 6 different secrets, is because we have 6 volumes that are encrypted. We have data and log for every node. We have 3 nodes. 3 times 2 makes 6. I know it because my daughter is learning timetables. Okay, so if I do that, xdump-c, you should see at the very beginning, if it works, you will find v1 vault provider, and then just gibberish everywhere. So it means it's encrypted, right? So if you want to check the same thing with a secret that is not encrypted, you would have to replace the last portion again with the name of a secret that is not encrypted. But I have encrypted all my secrets, so I'll leave it up to you to change this. Okay, so now I think we are done. We have what we have done so far. We have encrypted, decrypted secret with Vault. We have configured Kubernetes API to enable encryption. We have configured Trousseau. We have created a database cluster. We have encrypted the volumes, and we have made sure that the secrets used to encrypt the volumes are also encrypted. So you can check the lab. And if everything is fine, you should go to the final stage that you should take a screenshot of that one if you want, just to prove that you have finished the lab. And also, or you could take a screenshot of this screen as well, and say how much you enjoyed it. Maybe not this one. No, don't use this one. I'm gonna be using that one. Not that it's because I wrote it, but actually, yeah, probably because of that. Finished. Okay, so let's go back. I think now we are good to go to the next stage. Bart, are you still there? Are our panelists there as well? We don't hear you.
Oh, can you hear me yet? Now you can? Yeah.
So let me just unshare and remove my screen, and I'm gonna add everyone here.
Good. What's up, Allison? What's up, Lorraine? Good to have you back, Dominique. Yeah. First of all, I think we can all agree, big shout out to Nick. It's not easy to do a lab like that in general, let alone where
I'm sweating a little bit.
In the final stretch, you start getting Shakespeare in there. Anyway, you've made history. I've never heard. I don't know when the next time we'll be able to hear her talk about encrypting Shakespeare.
Yeah, when was the last time you heard about Shakespeare?
And when, particularly in this context. So anyway, really enjoyed that. As a reminder, folks, for the raffle part, it's quite clear what you got to do. Take that screenshot. Let us know that you're finished. That you need a tag and to make yourself visible so we can get you your swag. Now moving on to the next part, and just also a reminder though too, get in Slack if you're not in Slack already. All the people who are with us right now on the panel are in Slack. To get started, since we already got a quick introduction from Nick and Dominique in the beginning, I would like now to turn it over. Allison, with those headphones, you've got to go first. I'm sorry, Lorraine, but it's tough competition. So Allison, can you introduce yourself and just let us know a little bit know about who you are and what you're doing at Kasten?
Hi. So yeah, I'm Allison. I do developer relations over at Kasten, and it's gosh, I'm a little bit nervous, not going to lie here. But we specialize in Kubernetes backup and recovery. And we've got a bunch of open source projects and online learning hub as well, learning.kasten.io, our product K10. It's pretty cool. There's a free trial, can check it out. Outside of the work things, or still inside of the work things, I work closely with the Kubernetes community as co-chair of SIG Contributor Experience. And I'm also CNCF ambassador, and really looking forward to KubeCon happening in Valencia in May. So yeah, it's a bit about me.
I think we all are, all of us that are connected in Europe. Now to turn it over to you, Lorraine, can you just give a little bit of background about who you are? Oh, you're muted. Lorraine, you're muted. And let's see, can we get you unmuted? Oh, we lost Lorraine. Lorraine will be back. That's okay. Lorraine wants that much of a disconnected. She wants that much of a powerful.
Oh, she's back.
She's getting.
Here you go. Yeah.
Hey, Lorraine, how you doing? Yeah.
Hello. I'll try again. I'm Timescales community manager. Timescale DB is a time series database that is underpinned by PostgreSQL, so you can use SQL for your time series queries, and optimizes storage and makes everything wonderful for time series data aficionados. And we also have PromScale, which is a observability platform. So that's my quick intro.
That's a good intro. Lorraine is a very active person in our community, very accessible, as is everybody who's here with us on this panel. So anyway, that being said, we just want to jump right in. We've just had a really good technological overview from Nick about secrets, about encryption, and all things that are very, very relevant to our community on the technical side. However, now we want to kind of balance that out with the human side of things. And so, we're as Allison rightfully mentioned, we're all hopefully going to see each other in May in Valencia, fingers and toes crossed. Hotels getting booked. We're going to have a co-located event for the Data on Kubernetes community. Hope to see everybody there. But with that in mind, Allison, I want to start with you, is that, we're coming on 2 years of the pandemic. And so we've very much shifted to this online format, also hybrid format. what would you say has been, and also you're very involved in the CNCF as an ambassador, involving contributor experience. What would you say has been the role of community? How has it shifted throughout this period of time we've been going through? And what are some of the lessons that you've learned?
So the role of community, really, it's kind of crazy when I think about the pandemic and how like everything started out and shaped out. There was like a lot of things that kind of changed over time. For instance, everyone had way less bandwidth, especially in the open source side when we think about Kubernetes and bringing it back into developer relations. People are super busy, and so the kind of the huge shift in what kind of content or what talks and how we deliver information has changed a lot. And I see a lot of people bringing their own creative flair into their content and things like, for instance, Bart, your raps, they're honestly, you're dropping fire bars, I'm not gonna lie, like and it's the kind of mixing this kind of creativity with this educational piece of like, this is how you do Kubernetes secrets, this is how we do data management, this is how we do DevOps, all these kind of things, and adding your own kind of personal touch to those kind of things. And I think especially one thing the pandemic has taught me as well is the war for kind of, well, not the war, excuse me, that's kind of bad language. The trying to kind of grab people's, there's just so much content out there on Kubernetes at the moment. And if there's anything I could say about like, there are so many videos and so many ways to learn and all that is, don't be discouraged if you want to make your own kind of content or, you want to give it a shot. You want to teach someone something new. Because the thing is, we all learn in different ways. And so hearing stuff from a different voice, a different perspective, it's pretty cool. But yeah, I just kind of went on a tangent there. Yeah.
No, but I think we can all agree with that. I think you touched on a few different points in terms of the opportunities that it's given us in terms of ways that we can connect, and how we're connecting right now. I'm in Madrid. You're all in the UK. These international connections have certainly helped out a lot, as well as giving people a platform that they didn't necessarily have previously in order to do that, and as well as the kind of creativity that these sorts of environments tend to invite. And obviously, we just had a wonderful presentation from Nick that was being done in an online way, which means engagement changes, all those different kinds of things. Now, I want to turn it over to Dominique. You've obviously been very involved in communities in the UK, and some activities have kind of gone a little bit on standby. But what are the things that you think that have made these relationships last through this period of time? And what are other things that you think that we can expect as the situation progresses? Once again, fingers and toes crossed that things are improving. So don't want to jinx anything, but can we get a little bit of perspective on that?
Yeah, of course. So I think just to note a little bit of like, obviously it's amazing that like the pandemic has forced us to like come up with different and creative ways to do things. The flip side for me personally has been very much like, because everything is happening online right now, how am I going to stand out with my measly community meetups and stuff like that? Like, the pandemic has been quite hard for my mental health, and I'm happy to be like transparent about that, because it's something that we need to talk about as a community, I believe. I've allowed myself to just like put things on standby, because one of the things that I care about the most as a person is like the meaningful interactions where I can see people's faces. Like, this is good. Like, I like this setup. I like this format. But sometimes I'm doing workshops with customers for at work and stuff. It's like 200 people just like on the screen, which is fine. I mean, just names and stuff like that. But it just, I feel like there's still something missing for me personally. But I think that's one of the reasons why things have been a bit on hold. But also now things are becoming a bit more safer, because I don't really want to be the responsible person for people getting ill or, whatever. There's like a duty of care for the people that you manage, really, as a community. Like if you put people in the same room and all of a sudden, if you don't put the right health checks in place and stuff like that, or at least some sort of, like encourage mask wearing or social distancing or stuff like that. People need to feel safe, and if people don't feel safe, they don't share. If people don't share, then you're not really, you're there to learn something from each other, and everybody has something to bring. And I feel like what I'm mostly looking forward to is being able to actually go in and have a conversation again, because a lot of people won't feel comfortable enough to actually ask questions or engage with a conversation. And I'm very outspoken and very extroverted, so like I just get involved with everything. But I know for a fact there's a lot of people that won't get the same face time or amount of ability to actually share their thoughts and their things that they've built and stuff like that, because the barrier to reach out to people can be very easy, because it's, like everybody online can easily reach out to the people, but then getting over yourself and say, hey, can I come do a talk at your session? Like, do a session at your meetup, or can I ask some questions? It's very difficult to be more vulnerable, I think, if you, I don't know. I think I'm also going off on a bit of a tangent.
No. I think you raised several good points there. One thing is that I think the pandemic has helped us be much more open about mental health, and being transparent about that. And I +1 everything you said about that I've definitely suffered a lot, and it's made me question and have to have different strategies and apply creativity and openness to being open to different ideas regarding that. And also what you said too is that as folks that are in outreach positions, which is a privileged position as well, I would say, at least in my case, is that not the same strategy isn't going to work for everybody. And we saw, like, just in this, just in the hands-on lab, get your questions. We say it again and again, but some people are still going to struggle with that a little bit, and we have to be sensitive to that and know. And then you're like, why didn't they ask the questions that I wanted them to ask? Well, there are a million different factors that can play into that, and you don't know what kind of a day somebody might have. Different things can happen there. Now I want to bring it over to Lorraine, and Lorraine, you can give a little bit of context about this, because Lorraine actually did academic work about looking at the effects of loneliness. So I do want to draw on you here, Lorraine, about how this has also played a role in the pandemic. And once again, that, like I said, we're talking about technological challenges, but in order to make people feel comfortable to tackle those challenges, to be engaging in a community, we have to be sensitive to these things. So Lorraine, if you could just give us a brief summary of the work that you did. I believe it was when you were you did a master's degree on this.
I did.
Yeah. Can you just give us a little bit of background about it and how that might apply to the situation we're currently facing right now?
Yeah. No. I can. I'm kind of digging back into that work now. But yeah, you're absolutely right. There's kind of loneliness and building community and being alone in the pandemic is like a kind of a big issue. And the work that I did was looking at the whole idea of kind of elderly loneliness, actually, and kind of just being isolated with kind of your pet. And I kind of did a storybook, kind of a collage about that kind of journey that people have to combat loneliness, which I shared with Bart, so that's why he knows about it. But I think that kind of coming back to that also, I think that as community people and developer relations people, we also have to recognize that when you go to conferences, there are people that can be very lonely in that space as well. Because, and one of the things that I've been with Timescales since July, and one of the things that I have really appreciated, if we could look for some good in this pandemic and how we've had to work, because that's, me, I like to try to find those good bits and those good nuggets, is that because I've been here since July, I've been able to build relationships with people online in a way that if I'd been going to meetings and meetups and conferences all the time, because you tend to get this kind of traveling troupe of kind of conference goers and things, that in itself builds a clique. And that in itself is exclusionary to those people who are just turning up to like one conference. So what I've appreciated about the pandemic is that kind of ability to be more widely equitable about who's included, because you can join from anywhere in the world. It's not financially kind of driven. You know, you don't have to get permission to come along. You don't have to be able to pay for your hotels. So there's those elements where some of the people that are able now to join in the community and be wholly a part of it, because the conferences aren't happening, can engage, you know. So that's kind of, I mean, the last conference I went to, I was there as an attendee, and I did actually feel quite lonely, and that brought it really home. It was a DevRel conference, ironically, so you would think you would not be alone in that kind of context, but there were these kind of real kind of groups of people, you know. So it's kind of breaking into that is quite important. Dominique, Dominique,
no, I was just that thing that I just wanted to like touch on that, like the experience of going to a conference or a meetup by yourself is terrible, you know. Like as I said before, like I can easily talk to people if I want to, but as soon as my social battery runs out, I'll just sit in the corner somewhere, listen to music, you know, put like a noise cancelling headphones on, and then I'm just in my own brain for a bit. But it's you know, like I've been trying over the last couple of years, I've been trying to come up with like clever ideas of like how can we encourage like the more togetherness. And yeah, I think it's interesting. I went to DockerCon in Barcelona, and they did this really interesting thing where I forget what it's called, but basically if you're a first time the DockerCon goer, you can sign up to this put an online form. You get like paired with one of the Docker captains or one of the community leaders. Basically, just get paired with like a group of 10 people, and you just like have lunch together, or just like you're able to discuss the content that you've seen and stuff. I thought that was really cool, and I think that should be done a bit more, you know. It's just like how that does particularly translate to in-person things, and I think in the sense of like being online, or at least having at least some sort of hybrid solution for it, you know, the ability to join and feel like you're part of something is easier. But yeah, like so yeah,
I think those are really good points, and I myself as well too identify very much, because I think I would certainly imagine that the sort of personality that's projected through, the guy who makes rap videos, he'll go up and talk to anybody. Sometimes yes, but then other times I'm very much like in social situations where like I'm just gonna go pretend that I'm on my phone doing something important, when in reality it's probably not that important. I just want to like zone out and listen to music or things like that. And because those situations can be very taxing. One thing I do want to mention, and also I'm trying to give Nick a chance to breathe, and Nick continues to answer questions in the chat while we're talking, doing his due diligence as a wonderful DevRel person, is that I want to turn it over really quickly to Allison as well too, is because I'm lucky enough. One of the main reasons why I've been able to find my sort of niche in this world is because of getting started in the CNCF through the contributor experience upstream marketing group of telling stories about different contributors and things of that nature. And once again, talking about, you know, what Lorraine was mentioning of, you know, really building a big tent where you insist on being welcoming. And I had never really experienced that in anywhere else, but it was because of the welcome that I received when joining the CNCF in that capacity, and was immediately able to, it was like, if you just want to sit in the meetings, basic requirements, open source, positive attitude. Second, being willing to learn. Those are the things that I continually insist on. And personally, because I do not have a technical background, I am not a programmer, I'm not a DevOps expert, none of that. But people in my experience in the CNCF is like, don't worry about that. There are other things that you can do. And I really insist on that as well too in our community. But Allison, if you could just touch on that briefly about that sort of spirit. But I would also ask, it does take some work to continue to build that. It's not something that just comes and, you know, you just leave it and it's there. So if you could just tell us a little bit about your experience and what's necessary to make sure that communities have that, so that people do feel that welcoming experience and that they have a role to play.
So if there's anything I can say to that point is, so my experiences personally, like getting started with Kubernetes and starting to contribute upstream was, I remember this, I went back ages ago. I was in Barcelona at Kubernetes Contributor Summit. I was at this new contributor workshop. And I remember, you know, I did a little bit of helping out, like I was helping run around the microphones. And there was Guinevere Sajana. She was like to me, "Oh, you should come help next time," and she kind of extended the olive branch out to me, and I'm like, "Yeah, I'll come help next time." And then, you know, I think that's a huge part about being welcoming and inclusive is, you know, getting new folks in to do work, to participate, to be part of this kind of wider thing. And on top of that, you know, providing opportunities, because, you know, there's a lot of work out there when you're contributing to an open source project where you can see something that's like should go fix it, and you're like, I could go fix that right now, but you could actually, like, you know, stop and pause and give an opportunity for someone else to come to the table, rise up, and, you know, get that first, you know, experience of contributing to a project. And that's kind of, you know, I will have to say I'm not perfect myself. I've been through kind of, you know, periods of time where I feel like, oh, I have to do all these things myself, and, you know, you end up overloaded. Then you kind of look around and you're in this wonderful kind of community of people who you can reach out to for help, who you can, you know, for instance, even earlier today, you know, I was supposed to host a meeting for contributor experience, and you know, I reached out to one of my fellow contributors, Chris Short, and I was like, please, can you host the meeting? And, you know, it's that kind of teamwork that you can rely on those people. And, you know, and on top of that, I had to say with the community as well, like, because of how diverse in nature it is. So we've got folks from, you know, in contributor experiences, folks from all over the world, from, you know, America to India to New Zealand to the UK. And one of the things we do to make sure we include everyone is, instead of having we have weekly meetings, but we have one of them that's face-to-face and bi-weekly at a certain time. And then one of them's an asynchronous Slack meeting. And that gives folks who might not be so kind of comfortable with coming on camera or coming on a call an opportunity to kind of participate and be part of a meeting. So yeah, it's a little bit of a tangent there, tangentially speaking, with the tango. Good drink. I had that pizza earlier.
This is not sponsored by Tango. Just
This is not. It could be sponsored. It could be, but it's not.
Is it still a thing?
If they want to sponsor, they can. But we're
reach out to us.
Yeah, we've got all our Twitter.
Tango.
Now to turn it over to Nick, because I think Nick's been able to answer all the technical questions. So Nick, you know, you're directly working with, and, you know, and this is one of the challenges that we really face as a community, is that when I go out there, you know, I have friends that have been working with big data technologies and have cloud experience. And I say, oh, well, what about data on Kubernetes? And they look at me like, oh, you're totally crazy. Like, I'm not going to get into this. This is way too difficult. I think in roles of DevRel, dev advocacy, a lot of it is try, you know, there's, if you want to say enticement or encouragement, you know, when you want to be approaching folks and talking about, you know, writing stateful workloads on Kubernetes, obviously we just saw a wonderful presentation, but how do you go about approaching that so that it doesn't feel overwhelming, to break things down into, you know, smaller steps? What's your approach to that?
Yeah, so typically when I'm talking to someone, and if I want to introduce data on Kubernetes, usually I'm starting to, you know, what kind of database are you using? I'm trying to go on the database, message queuing side, all the applications that are not today necessarily running as the main target into Kubernetes, right? And then the second question is, where do you run them? And usually it's not in Kubernetes. And if people already have Kubernetes, I'm just asking, you know, why? Because, I mean, I know like 100 reasons why not to do it, but usually I'm like, okay, but do you know that since day one, like 5 years ago, things evolve, and now we have a lot of tools to enable you to run data on Kubernetes in a way that is almost effortless, with operators and all these things. This is what this operator thing is really key to make data in Kubernetes on Kubernetes a success. So usually it's a mix of what data you use, who is managing your data, because the thing is, you need to, we want to be inclusive, right, as well. So you need to include DBA, right? Even DBA sometimes are, like, I always compare them, like, back in the day, like a couple of years ago, when software-defined networking started to ramp up, I was not really making fun, but all the old CCIE guys who kind of were in total denial, where no, software-defined networking, no, I like my boxes, I'm going to stick with my boxes, my Cisco tattoo. I mean, I don't have Cisco tattoo, but I could. And it's kind of the same thing, it's with data on Kubernetes, you have to forget the idea of running database on a bare metal server. It took time. It took probably about 7-8 years to get database running properly on virtual machine in VMware. So imagine in Kubernetes, because VMware is UI, click everywhere. Kubernetes is a bit more convoluted, more complex, a lot of more moving parts. So it's going to take some time. And this is why I love the community. And this is also why I used to contribute a lot in the Cisco DevNet community, because this is where the cool stuff happens. This is where you can talk to people. This is where you can educate people and share information and just talk to them. And this format, to be honest, like I'm not a big fan of talking in front of my camera. I don't see people. It's just names. And, I don't know how many, conference I did, but so many people come to you at the end of the session just to have a one-on-one chat because they're just not comfortable with, where they are in their journey and things like that. You cannot just do that anymore. And sometimes I've got people, actually now it's a bit different. They're pinging me either on Twitter or on LinkedIn, or like ex-co-workers or friends or people who watch my videos or blogs. They just ping me on LinkedIn and they ask me for, I use Calendly, and then just pick a slot there and we can have a chat. But I'm not a big fan of that because it's too... it's a lot more complex. You have to use LinkedIn, you have to use Calendly, you have to click. It's always in front of the damn computer, right? It's a lot easier. We can, at the end of the conference, you go for a drink or you go for a coffee, whatever, right? So, and this part has been very difficult for me. Yeah, I'm not gonna lie. It's very difficult.
I have to say
Online
that kind of
conferences are hard work. Sorry.
No, sorry. I could say that. The multi-channel switching thing on a day-to-day basis is really kind of, you're constantly flicking, and because you're meeting the community where they want to talk to you, it's kind of that has become really mind-blowing in this last few months. So,
that's a good point. That's a good point. And that's something that's being addressed well now in the CNCF. There's just a burnout group that's meeting every week just to talk about. And the thing is, the level of burnout rates among folks that are sort of in our positions, that are the ones that are on stage and also behind the scenes at the same time, it's something that it's taxing, and you have to figure out. And what Allison was mentioning either is sometimes you find yourself blindly going at, and Dominique mentioned as well, it can be easy to fall into the trap of doing everything at 100 miles an hour. And once you learn that you can do it, that's kind of a bad thing, because then you're like, oh no, but I've done this before, and really your limits
here.
The anxiety that increases, all that. So anyway, if I can say anything, and unfortunately we do have to wrap up, is that I think empathy is a very key element of this. And empathy is once again, it's not something that's static. It's something that needs to be nurtured. It's something that needs to be taken care of. And I think the next step, from this particular call that we're having right now is seeing how we're going to take that to the next level in March. And so that's kind of the challenge. So I'm looking forward. I hope to see everybody here in London. Mark your calendars, March 24th. We will be there. I have my flights. Hotels are really expensive in central London. I'm not going to lie. So I'm going to...
Maybe you should get one of those temporary room booking things. I'm not going to name any names.
Yeah, what I'm going to do is stay at a friend's parents' house is probably going to be my solution. But anyway, but like I said, really looking forward to that. But at the same time, it's a challenge because, this is going to be my first time doing an in-person event, I think, since the pandemic started. So once again, I think a big part of this in terms of how we're constructing it is this empathy element. If some folks, for a lot of them, it's going to be their first event to go to, so there are just different things we have to take into account. But I'm very much looking forward to it as a learning experience. And I've learned a lot today. On the technical side from Nick, amazing job. Learning about Vault 2 was super cool. Dominique, thank you so much. Allison, it was great to have you with us. Welcome to the Data on Kubernetes community. I guess you're one of our newest members. So very nice to have you with us. Lorraine, pleasure as always. We'll continue the conversation on Slack. We'll be separating this from the live stream, the previous one, so that we have it as a separate video for folks that just want to focus on these elements. I think we touched on some really good points here today. So thank you all very much. Nick, congrats again for an amazing lab.
My pleasure.
Really good. Take care, everybody.
Thank you for having
Thank you.
me, everybody.
See you next
Cheers.
time.
Take care.
Bye.
Bye-bye.
Bye.
Bye. Oh, how do I?